My name is Yufeng Guo. Welcome to the Dev Zone, and I'm joined today.
I'm Minhaz Kazi. Yufeng is developer advocate for machine learning and cloud AI, and I'm developer advocate for Google Data Studio. And today we're going to talk about from data to dashboard, a machine learning adventure. So the way it started is, once upon a time, Yufeng and I decided that we're going to build a company.
Some kind of a, maybe call it a startup, perhaps.
Yeah, so we'll have a startup. Now, Yufeng works in machine learning. I work in data viz. So we thought, can we put these two together and maybe create a company and then make lots of money?
Some kind of a successful company.
Yes.
Like a startup.
Yes, some kind of a startup.
Some kind of
Yeah,
startup.
that would be a good idea. Now, but what is this company going to do? Like, what are we going to sell? What are we going to make?
Just throw some ML and data visualization at it. It'll be fine, right? Like, we need to look at how we can make a turbo encabulator. Has anyone heard of a turbo encabulator? It's specifically, I got a spec here. It's based on the principle of data generation by the modal interaction of magnetoreluctance and capacitive reluctance. And the ML and turbo encabulator will negate the relative motion of conventional conductors and fluxes.
What?
Yep.
OK, let's just move on.
Let's just move on, yeah.
So what is our plan?
So we'll collect some successful information about successful companies from all over the US. Okay. And we're going to try to emulate successful companies. That's what everyone does, right? We try to emulate those that are successful. And we'll analyze that data. We'll do some machine learning, try to come up with things like, what should we call our company? Who should run our company? Maybe where do we want our company to be? And hopefully we'll have some profit with our turbo encabulator.
All right, cool. So this is the data set we started with.
That's right.
We used the Inc. 5000 data set of America's top growing companies, where there was data available for the top 5,000 companies that had the highest growth rate over total 3 years.
Yeah.
And this is what the data kind of looks like. It had information on the year the company was founded, the rank of the company on the growth chart, then the name of the company, when it was founded, which location it was founded in, the state, the revenue amount, and also the growth amount, the industry, and the headcount.
Yeah, and we were looking at this, we were just thinking like, maybe we can get something out of this to get some insights about what makes a company successful, right? Is it these factors, or is it something that's not necessarily captured in here? So this is a big list, right? It's over 5,000. It's not like
5,000 rows.
It's not a
wow.
50 company list or a 100 company list. We have 5,000 companies. That's some really big data.
Yes, and for very big data, we need big firepower.
That's right, and that means to search through this big 5,000 long list, we need some big queries as well, right? Yeah.
So we decided to put our data into BigQuery. And so we will put our 5,000 rows in BigQuery and run queries on it, run analysis, and try to figure out what makes these companies successful. So the data we had, we took the data and we put it into BigQuery, and then we tried to see what kind of visual insight we could get out of it. So to get the visual insight, what we did is we used Data Studio to connect to the BigQuery dataset and then take the data and sort of get some kind of insight out of that data. So to do that, we went to Data Studio. We selected the BigQuery. We picked our data set, and then we connected to it. So once you connect to it, it kind of gives you the overview of the data. As you can see, this is what the data looks like, the entire schema of the data, and then once we connect to the data set, it gives us a blank canvas where we can create our viz. So let's try to create our first viz. We'll try to add a bar chart, and we'll try to see the average revenue of companies. So I'll try to find by industry, the average revenue. And you can see there's a 0 here. 0 means for these companies, the industry was not defined. So let's try to filter that out. So we'll add a custom filter, and we'll create a new filter. We'll say exclude all industry that is basically 0. We save that, and you can see that the security industry has the highest average revenue per company.
It's because they're all securing that revenue, right?
Yes,
Security.
they're very secure about their revenues. And also the logistics and transportation, because they're transporting their revenues.
Exactly.
So we'll try to add maybe one more chart and try to look at how the exact number, or maybe how the number of companies look like across states. So we'll add the state variable, and we'll add the rank, or maybe record count. So how many companies are there from that list in each state? And let's apply some filters. And as we view the dashboard, we can see most of these companies are in California, then in Texas, Florida. If we try to, let's say, filter down, if we click on Virginia, it shows us that in Virginia, insurance companies are doing the best, and followed by government services, which makes sense because it's close to DC.
Exactly. And what I really like about this is that you were able to make a auto-filtering interactive chart without having to do any sort of like coding to make that clickable filtering work.
Exactly. And we did completely serverless, completely on Google Cloud.
Yeah.
Because the data was in BigQuery, and the viz is being done in Data Studio, which you can just use from your browser.
Yeah, super handy. Just like bing, bang, boom.
So we used this dataset and created a dashboard beforehand. This is what the dashboard sort of looks like. On the left side, we have number of companies by industry, and then we have number of companies by state in this geo chart. We're showing the average state of the companies that are coming up in this filtered view. When did the companies start? And there's also a sort of an insight from what are the outlier companies. So we have the top 100 ranks here and the revenue of the companies, and we can see that there are 3 outliers here. The first one is Carvana. Then the second one here is Avant, and we have another outlier here, which is the PantherX.
Specialty pharmacy.
Yes. And we can even filter it here. If we click on health, it will filter across all of the other charts and show you a filtered view of the entire data. So from this dashboard, we try to figure out, all right, which industry should we be in? Which state should we be in? So it looks like California is the state where we have to be in, because most of these successful companies are there. So if we establish our company in California, we have a very good probability of being successful.
That's right, because correlation is causation.
Exactly. So that was our dashboard. Now, the most important decision we had to make about our company. Can anyone guess what was the most important decision?
Right, we already did location. We already did industry, kind of, right? What other things, what other factors are there? What is the single most name? I heard name a couple of times. What should we call our company, right? It's got to be catchy. It's got to make sense, but be a little bit edgy, right? And so how can we make this critical decision? Well, we'll look to our data. We got 5,000 companies, and we can take that and we can stick it into a machine learning model that will actually generate us names that are similar to these companies, right? We want to be like them. We want to be like the top 5,000 companies. And so, if you have a lot of options, right, of how to do this. But basically what we did was we took the BigQuery data, pulled out that column, put it into Colaboratory, and ran a recurrent neural network to make those generated models, and we spit out some very interesting company names. And what's neat about this, I found, was that with generative models, you can set what's called a temperature. And the temperature determines how kind of creative the model decides to be, how wacky it decides to be. And on one end of the spectrum, you have extremely normal names that show up repetitively, or words that are very common, and so they're kind of safe. And on the other side of the temperature spectrum, you have really, really creative names. You might have, well, what might be viewed as misspellings, but sometimes that's a good thing for companies. And you might have things that just make no sense at all. And then in between, you have kind of in-between stuff. And so looking at this list, which ones do you think are real? Companies that really exist out in the world. And which ones we just completely made up, which is generated from the model, right? Can you tell them apart?
Let's take the first one. How many people think the first one is a real company?
Yeah, that first one is Sophie and Motors.
How many people think it was generated? All right.
Okay.
What about the second one, the Lollipop USA? How many people think it's real?
Lollipop USA is real? Okay.
All right,
And Lollipop USA is fake. So about half and half on that one. Interesting.
All right. We can do the third one also.
Yeah, let's
maybe?
do the third one, yeah.
Persoft, real? Persoft, fake?
Another 50-50.
Cool.
Who didn't vote? All right. All right, let's go on and take a look. So I guess we should give it away now. The left side are all fake, and the right side are all real. So Lollipop is real, Persoft is fake. And Sabat Consulting is also real.
It's also real.
Yeah, and so here are some other names that we generated in addition to those, and we've kind of colored it by this temperature metric. So at the top of the list are fairly creative company names. Now remember, these are all fake. Not a single one of these companies is real, okay? And then at the bottom are names that are really safe, similar, and you can see there's a little bit of a pattern. It seems that companies really like to call themselves solutions or systems or services, right? And they want to cover all the things.
So that gives us an idea that we will call our company All Systems Solution Services, trademark pending.
It would be the most successful company name ever. It would be instantly recognizable and etched into the minds of our customers.
Definitely. All right.
So this leads us to the other question, right? Aside from the name of the company is whose name will be in that CEO slot? Who should run the company? Well, we could use the same technique as we did before and try to make up some names too. We got a list of 5,000 founders, and they're all in the top 5,000 companies in the country. So, again, who's real and who doesn't exist? Raise your hands if you think Andy Guerin is a real person who runs a company in the top 5,000. Who thinks that Andy Guerin does not exist? Totally made up.
All right.
Okay.
Quite a few people think
Yeah.
Andy doesn't exist.
Or Andy.
How about Jeff Shaw? Jeff is real. Jeff is not real. All right. I think people are catching on.
Yeah, well, we got to look at the other side, though. Right? What about Dwayne Smith? Is Dwayne Smith a real person? Okay, and Dwayne Smith is completely made up, computer-generated name. So we got to really wake people up somehow. We don't have any cupcakes to throw at you, unfortunately, but I know it's still technically morning. So again, the left-hand side is fake, and the right-hand side is real. So Dwayne Smith is real, Jeff Shaw is fake, and we can see some other examples of names. We have some more creative names toward the top that are not, some of them, like the first one, what the last name, FRNI, a little short on the vowels and the letter ordering, but for the most part, these names kind of sound real for the most part, right? Especially the ones in the middle. They start,
Yep.
it's not the worst.
They seem like name of real people.
Yeah.
So
apparently the people like the name Jeff.
yeah, I think we should be hiring like Jeff Gardner or maybe Chris Martin to run the company.
Yeah.
But
But they don't exist, so we can't hire them.
yes, I know what we should do.
What should we
Let's
do?
change our names.
Oh,
You
yes.
can name yourself Jeff, and I can call myself Chris.
All right.
So,
Nice to meet you, Chris.
all right, nice to meet you, Jeff. So that way, since we've changed our names and we have these names, the model predicts that our company will be successful.
Absolutely. Of course. Successful name, successful names.
Yes.
So this brings us to the next question of, we don't just want to be in the top 5,000. We want to be toward the top of the top 5,000, right? And so let's take a look at how we might go about doing that. So I've got the data, right? We dumped it out of BigQuery. I did like a little bit of cleaning up on BigQuery, and the screen, okay, did a flash. And so we'll import TensorFlow and Keras, and in this case, I'm pulling it into pandas. And what I'm going to do is we'll try to take some of the statistics that are coming out of this data set and load it into a Keras model to basically try to build a model that can predict which quintile a given company will be falling in, given things like what state it's in, the growth percentage, headcount numbers, in its industry, and its revenue. And so, I've processed out like the quintile. So I added the quintile column in BigQuery to basically do a division by 1,000. And then, we can see some interesting statistics about our columns. Like there's, 26 unique industries in this data set. We've got 52 states, thanks to Puerto Rico and Washington, D.C. And we have, let's see, any other notables? The ranges of the revenue I found to be pretty interesting. I know it's written in scientific notation, so apologies in advance. But the minimum threshold to make this 5,000, the lowest revenue annually, was 1.7 basically million dollars. So these are not the smallest companies. But then when you get to the higher end, 4.7 times 10 to the 9th is $4.7 billion in revenue. And these are all privately held startups. So we split the data up into training and test. And here I've actually split it in half, just because we only have 5,000 companies. I'm not going to show the model all these companies. Then I have nothing to do predictions on. So I just showed half, and we'll save half to use and make some predictions on at the end. Then we'll grab the columns we want, split them down, and then I've got my training input functions, et cetera. And then what I've done here is use TensorFlow's feature columns, which is a way to kind of do some feature engineering. I find that having the right tool for the right task is really important. In BigQuery, making an extra column for quintiles and doing a little bit of like date manipulation was really easy. And so I did it there because it came to mind. But then as I went through the process and I was in pandas and I was doing a few things there, those were like the discoveries I made there around what I needed to do. I could just do them right then. And then when I actually started loading it into the model, I realized, things like growth, it's just a number, and the growth kind of ranges all over the place. So I took the quintiles, the percentiles, the 25th percentile, the 50th percentile, and the 75th percentile values for some of these columns and bucketized them, so that because I don't care if the growth is 40% or 50%, like that's roughly the same thing. And so I want the model to recognize it as such. And I've done the same thing here with headcount and with revenue. And revenue is especially notable because the ranges are kind of all over the place. And so knowing where the percentiles are helps you get a nice even distribution of your data across the buckets. And so with all the feature columns set up, I made two different models, a linear model and a deep learning model, right? So the linear model did pretty good, I'd say, all things considered. When I finished evaluating, we came out to about 76% accuracy. I could keep training longer. I could keep banging my head against the different features and different columns, add more data. But all things considered, given that the insider piece here was when I first started doing this and I didn't have any buckets at all, I was getting like 20% error accuracy, which is terrible, right? So the changes really made a meaningful difference. And on the deep model side, I just kind of made a simple model. It's a 3-layer model with 20, 15, and 10 neurons per layer. So not terribly large, not terribly sophisticated, but with that and training for the same amount of time, it got 86%. So still not perfect. I'm not looking for perfection here, but just seeing if we can actually model this behavior. And it seems like we can. We can use information like headcount, location, revenue, and what else? Growth percentage, things like that, to actually predict, the successfulness of a given company. And so here we have a few. See, I already set this part up. So we have the different industries, just so I don't have to type them all. So if we want, we can actually generate our own fake company. We can say, I want a company that's in the state of Maryland and has had a growth of 203% over the past 3 years, right? I've doubled over 3 years. pretty reasonable for a startup.
Sure.
Maybe but I've only got like 58 people. Hiring has been a little bit slow. And let's see, what industry should we be in? Does anyone have a preference? Feel free to shout it out. Human resources, okay. So we'll be in human resources. Where is human resources? Here we go. So we'll copy that, and we'll put that down here in our industry array. Oop. Okay, so human resources, and how much revenue do we want to have? So we know that on the low end of things is about 1.7 million, and on the high end of things we got about 4 billion. So depending on whether you believe revenue is a big indicator for growth and success as a company, with only 58 people, how much revenue can we really be expected to pull in?
100 million.
100 million, what is that, to the eighth?
Yes.
All right, so we'll say this much. Whoop, did not. Gotta love the present. All right, still remember how to use the computer. That's good. Okay, so that's 100 million, right, to the eighth?
Yep.
All right, so let's run that. And let's see, then we can, I think where's the cell for actually, oh, right, because I'm writing it to a file now. All right, so we'll just write those results to the file. I don't know if that's going to work, though.
So this is going to predict where this company is going to end up in the ranking, which quintile, whether it'll be among the first 20% or the next 20%, it'll predict that.
Yeah.
That's cool. So then we can potentially predict that if we have a company that's founded in California, has a growth of 5,000%, has only 2 headcount, we could try to predict if we are going to end up in the first quintile.
Yeah, I mean, that kind of sounds like the early days of Google. A little bit, right?
Or the early days of all system solution services.
All system solution services, yes, thank you.
Definitely.
Yeah, and so what we've actually gone ahead and done is we took the other half of the data and I ran it through our model, and we outputted a CSV and passed that over to
Google Sheets.
To Sheets.
And then from Google Sheets, we have this data, which shows the comparison of the actual versus predicted values.
We're trying to click, but it is.
Yep. All right. Yep. It came up. So this data set basically shows what was the actual values of the comparison, and then what did it what was the predicted value. It is waiting for cache.
Waiting for the Wi-Fi.
And it is loading. So as we did that, we have the actual value and the predicted value. We try to take this data set and try to see that can we visualize this again. So we again went back to Data Studio, and then we added back the data and tried to visualize that. And you can connect Data Studio dashboards to a Google Sheet, so that we did exactly that here. We connected the dashboard to that comparison data sheet, and let's say we will add a new chart. And we will add a, this did not get picked up. When our company gets up and running, we'll have to fix our Wi-Fi.
That's right.
Yes.
Tell our employees to stop streaming movies while we're presenting. Can't have that.
Now, so this is our actual quintile and predicted quintile. And you can see the comparisons come up. And since this model was pretty accurate, for most of the companies, this is exactly the same. Now, we can try to add filters here and try to see, can we find something where these are not equal? So let's say we will try to filter by state. View this dashboard. And we should be able to then filter it and see whether there are other data sets where these don't match up. So If we filter for Virginia only,
Yeah, we got a lot of West
Oh.
Coast love, so we'll do a little East Coast.
yeah, it's still mostly the same. So maybe there's one or two hidden in there.
Yeah.
So that being said, we showed you how you can take the outputs of the model and then publish the insights using a Data Studio dashboard. And you can then take this dashboard and then you can share it with other people. You can publish it and embed it on websites. So you can go from completely a blank data set, like a new data set, to a published dashboard results in a few minutes, in a few clicks, in a completely serverless environment.
Cool.
So that's
our
basically
final-
tells us like our company will be called All System Solution Services. We'll be creating.
And soon to be in the big
Yep.
5,000. Yeah.
Yes.
And so we have a blank slide. So yeah, thank you so much for coming. My name is Yufeng. This is Minhaz. And yeah, or I guess we are All System Solution Services.
Yes.
Trademark, copyright, registered, pending. Cool.